Unit 8, Objective 2 for Week 1 talks about finding the GCF of an expression. So what is the GCF? Remember that the GCF is simply the greatest common factor, or the largest number that will evenly divide into every number in an expression or a list. There are two ways that you can find the GCF. There's the slower method where you would make a list of all the factors of each number. Then you'd find the largest number that is in all of the lists. You probably used this method when you were in elementary school or middle school, first learning out about the greatest common factor. The quicker method, and the method that I will be showing you here, is to make a list of all the factors of the smallest number. This is because if a number is larger than a number, then it won't divide evenly into that number. So by making a list of the smallest number, it's possible that it will divide into the other numbers. You will then start with the largest number in the list and check to see if it divides evenly into all of the other numbers. You start at the largest because you want the largest number that divides into everything. If you start at the smallest, then you'd have to keep going until you couldn't find another number. So we're going to look here at this first example. Find the GCF of the following groups of numbers. So we're looking at 30 and 45. Since 30 is the smaller number, we're going to go off to the side and we are going to list all of its factors. So we always know we can start at 1 and 30. It's even, so we know 2 will go into it 15 times. The sum of the digits do add to 3, so we know 3 will go in, and that is 10 times. 4 will not go into it. One way to check 4 is to see if 2 will divide in twice, and that's really just checking, is the other factor with 2 even? So 4 doesn't work. 5, it ends in 0, so we know 5 will go in, and that is 6 times. And we are back at 6, so we know that we are done. Now we want to see, of those 8 factors, which one will divide into 45? That's the largest. So we start at 30. 30 doesn't divide into 45, so we cross it off. We look at 15. We know that 15 will go into 45 3 times. So we know that 15 is our GCF. If we had started at the bottom, then we would have had to keep going through our list. So we would have said, okay, 1 goes into 45, so 1 works. 2 does not, so 2 does not go in. 3 will go into 45, 5 will go into 45, 6 will not, and 10 will not. And then finally get to 15 and say, oh, 15 does, but we'd still have to check 30. So by starting at the largest, we can be done much quicker. It doesn't matter which way you go, it's just the more efficient way is to start at the largest. So now let's look at 12 and 48. 12 is our smaller number, so we will make the factors of 12. So starting at 1 is always a factor. It is even, so 2 will go in, and 2 goes in 6 times. 2 plus 1 is 3, so 3 works, and that is 4 times. And then we're back at 4, so we know we're done. Now we want to see what of those numbers will divide into 48. So we start at 12. 12 goes into 48 4 times. So we know that 12 is our GCF. This is one where there would have been a lot more, like 1, 2, 3, 4, and 6 all go into 48. So we would have to keep going. But by starting at the largest, we know we're done at 12. 16 and 64. So we find the factors of 16 because it's the smallest. 1 is always a factor. It's even, so 2 works, and that's 8 times. 6 plus 1 is 7, so 3 won't work. And then 4 times 4. Since that one is a perfect square and it repeats, then we know that we're done. So then we're going to start at 16. Will 16 go into 64? And it does. It goes 4 times. So 16 is our GCF. Again, had we started at 1, we would have had to go through the entire list to see that 16 is the GCF. Now, take a couple of minutes and find the GCFs of the rest of these 3 answers. or really of the next 6. So now check your work. You see that the GCF of 9 and 30 is 3, 20 and 125 is 5, 22 and 55 is 11, 80 and 24 is 8, 32 and 36 is 4, and 18 and 27 is 9. So in the last 2 examples I did at the top, we saw that one of the numbers was the GCF. And if you forget to write the 1 in the number factor, then you may miss that GCF. So that's why that first factor is very important. The rest of these, it was just another number. Now let's talk about finding the GCF with variables. Finding the GCF with variables is actually a lot easier than finding the GCF with numbers. So you want to write all of your variables in expanded form. So for instance, x to the 4th is x times x times x times x. X to the 6th is x times x times x times x times x. And it looks like 5 times x. Then you want to see how many they have in common. So we see there's this pair, this pair, this pair, and this pair. So there's 4 pairs in common. I have no more x's in x to the 4th, so I can't keep circling things. So that means the GCF of x to the 4th and x to the 6th is just x to the 4th. So when we look at x squared and x to the 5th, x squared will be x times x. X to the 5th will be x times x times x times x times x. Then we circle our pairs, and we see we have 1, 2 in common. So the GCF is x squared. It works the same if you have multiple variables. You'll just do the expanded for both of them. So x to the 5th, y to the 4th is x times x times x times x times x times y times y times y times y. And x to the 6th, y squared is x times x times x times x times x times x times y times y. Circling our pairs, we see that we have 5 x's in common and 2 y's in common. So our GCF is x to the 5th, y squared. It is important to note that the x to the 5th came from the first expression, while the y squared came from the second expression. So it doesn't necessarily have to come from the same expression each time. In the next video, you're going to look at how to take the GCF and find it for an entire expression, variables and numbers combined.